Thank you. Thank you. Then we can start now. Thank you. Thank you, guys. Let's go. Let's go. Let's go. Let's go. I was saying we're going to start on trigonometry. What is expected in our test that we are going to write. We are going to have like a question paper, more or less like this. You said it's number 13 and trigonometry, né?
Yes.
And I believe you have not yet done trig functions.
We started with trig functions actually.
Yeah, but I don't think it will be part of the test.
Okay.
Yes. I don't know with your teacher. So the first question there, if we look there, guys, this is 3 marks, if I may say, 2.1 there. By the way, before we proceed or before we do this question paper, any questions that you have for me or anything that you wanted us to talk about?
Can we talk about angles of depression and evaluation?
Elevation.
Yes.
Okay.
Elevation.
And depression.
Yes.
Okay. Do I have anything on that? No, we don't have here.
Wait, sir.
Yes.
Can we do the proving of the parallelogram?
Proving of parallelogram, the one that you saw here.
Yeah, and the other one. Proving A and B.
Okay. 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 We will do this one. We will do this one. I want to make sure that we are able to do the basics first. If I may ask all of you. Yes, we will go to that parallelogram. First of all, can I ask, like, are we able to do this? Let's start with Ntabiseng. Ntabiseng?
Okay.
There is question 2. Anything that you think it can be hard for you? These are 3 marks question, and we expect them to be there in the test. So we want to make sure that you pass. That's our intention for this lessons. Question 2 there, trigonometry. 2.1. Let's check. Ntabiseng, are you winning?
2.1.
Yeah, by just looking at them, do you think you can be able to do them?
Yeah.
Yeah, if you can check. Yes, Ntabiseng?
So are we substituting only?
Yeah, it's substituting and then taking your calculator. You see, they said correct to 2 decimal places. So it means, you know, I don't want to like waste your time, but I just wanted to make sure that you guys are able to do these questions. What I'm going to do there, it's sine what? It's sine x plus y. So this is equals to sine, open bracket, 229.5 degrees plus 117.6 degrees. Then you have substituted. The teacher must give you a mark for correct substitution. Then what you do, you take your calculator. If you can take your calculator, take your calculator and press sine. It will open a bracket there. Do it. Sine, press sine, then to open a bracket, then press 229.5 plus 117.6, then close the bracket. What do you get?
Negative 0.22.
Okay, I believe that is Tendo. And then Ntabiseng, what you get?
Same thing.
Thank you. So what you're going to do is this is negative 0.22. Going to choose the small places and then another mark. This is all that is expected. Even in this one, And this one, 2.1.2, what are going to do there? We're going to say 2 cos 2 what? 2y. Then cos open 2, it will open a bracket. Obvious, then we'll press 2 and then we'll press a multiplication or an open bracket. Then press a multiplication, multiply by what? By 117,6. Then we close the bracket. Then we find the answer. Then 2.1.3, it's obvious, tan what? X, that would be tan 229,5. Then we get these 6 marks, which is for free.
Yes.
Be saying, I heard Tendo saying yes. Are you happy? 2.1 Tabi saying, you will get
Yes,
all the
sir.
marks. Because you know why I'm saying this? I'm very sure that in that test that you're going to write, these questions must be there.
Mm-hmm.
Yeah, this is confirmed. They must be there. Then let's go to 2.2. In 2.2, we are solving for what? For x or for theta or for beta. Okay.
Yeah.
Are you happy with 2.2?
Yes.
Okay. Tendo is happy. Ntabi saying, are you happy?
Yes, sir.
Thank you. So Tendo, since you are the first one to say yes, please help us here. 2.2.1. How are you going to do it? I just want to know.
Take cos the other side.
We're gonna put 2x equals 2 and then cos -1 and
Cos
in
inverse,
brackets.
cos inverse, cos inverse. Language, it's important.
Okay, sorry. Then we put 0,50.
Okay, which is 0,5. Okay, close the bracket.
Yes.
2x is equals to what?
2x is equals to 60.
60. Okay. 60 degrees. Must be
Yes.
And then
And then we divide by 2 both sides.
2x divided by 2 is equals to 60 degrees divided by 2. Okay.
And then x equals to 30 degrees.
X is equals to 30 degrees. Thank you. So where 1 mark for that, 1 mark for your final answer. Then Tabi saying you were the second one to say yes. So you're going to do for us 20. These are free marks as I'm indicating, so I just want to confirm whether maybe we are suited with this way. Yes. Let's go 2.2.2. 2.2.2. Let's go.
Sir,
Tell us.
Okay, take the -11 to the other side so it can be a +11.
Thank you. I'm happy. 7 sine x is equals to 11. Yes.
Equals to 11. Then divide everything. Yeah. Take the yeah. What am I doing? 24x. What else? I think we should divide all of them with 7.
Thank you. So your step number 1 is to put your trig ratio in standard form. So when you have done like this, you have put the trig ratio in standard form. After you put the trig ratio in standard form, then you can solve for the angle. Your angle here is x. Okay, so x is equals to what?
11/7.
Ah.
Oh, take the sin the other side.
The sin. Is that what you told your mama? Today I was doing sin. Sine inverse. Or arc sign. And it's arc sign or sine inverse.
Uh-huh.
Yeah, arc sine or
Then
sine inverse. Yes. Then you take your calculator. What is the angle?
negative sin. Wait. Divided by 7 close brackets. Ah.
It's a
Oh.
math error. There's no solution, I think.
Let me check with mine. And have you saying you see now? You want your mom to kill me? Okay. I believe you now. No solution for this one, eh?
Yes.
Mm-hmm.
No solution.
Is that why it's out of 3 marks?
It's what?
Is that why it's out of 3 marks? Because there's no solution.
Might be, but maybe one of the marks is that you need to put it in standard form. It's
Okay.
putting in standard form 1 mark and then telling us that no solution or your final answer will be 1 mark. But this one is already in standard form. Remember, when we are solving for an angle in trigonometry, the problem or the most struggling part that most learners have is to put the trig ratio in standard form. So this one, it's already in standard form. That's why it was 2 marks. But this one is not in standard form. Here we've put in standard form. So it is important to put the trig ratio in standard form first. Otherwise, we won't be able to get the correct answer. Then we are about to close. You see, this is very fast. We are about to finish the trigonometry here. And then we'll go to those questions that are very interesting. She wants us to do them. She has no time for these ones. 2.3 then. Any problem?
So is it that thing Cartesian plan? What?
Cartesian plane.
Yeah.
Okay. So I want to know. First thing first here, we have cos x is equals to 3/4, and the angle x is between 0 degrees and 90 degrees. Then the question is that determine the value of tan x. So we are looking for tan x. And then all of us here, we agree that tan x is what? Is opposite over adjacent. Is that true? Yes. And then we know that cos is adjacent over hypotenuse. Okay.
Yeah.
Meaning, therefore, our adjacent will be 3. Our hypotenuse is 4. And here we need the opposite, which is the value of y. And then also the adjacent, which is the value of x. So on this one, we do have the value of x over the value of y. So if I can put it aside, we are told that cos x is equals to 3/4. And this 3/4 is the same as x over y. Meaning the value of x is what is 3. The value of, sorry. It's not x over y, but it's x over r. So meaning the value of x is 3, the value of r is 4. Okay.
Okay.
So we are looking for, I can check it back. We are looking for, this is what we are looking for. We are looking for what? For tan x. And tan x is equals to what? Is equals to y over what? Over x. of which from this trig ratio, we do have the value of x, but we don't have the value of y. You see that?
Yes.
Then it means that to find the value of y, we need to solve for y using Pythagoras theorem.
Okay.
And then before we just jump, we need to check where is the angle. The angle is in quadrant 1. Can you see that?
Yes.
Then since the angle is in quadrant 1, it will be very wise for us to do this diagram. It will be wise for us to do this diagram. Why is like I have over zoomed the paper? Okay. Can you all see?
Yes.
Thank you, thank you.
Mhm.
Can you see?
Yes.
Okay, thank you, thank you. Let's see. It's very wise for us to do this Cartesian plane before we do these problems. It would be very wise. So this is our quadrant 1. This is 0 degrees. This is 90 degrees. So we are told that our angle x is between 0 degrees and 90 degrees. So the angle that is between 0 degrees and 90 degrees will be like here. There it's our angle what? Angle x. There is our x. Then there we complete our right angle against the what? The x-axis. The x-axis. So what we see here in this trig ratio is that the value of x, meaning from the origin to this point, is what? It's 3, meaning here it's 3. And then we see that the value of r, which is the hypotenuse side, it's what? It's 4. What we are left with is this side, which is our y, or this coordinate. We don't know it. So that's why we use what? Pythagoras theorem. So we'll need to solve for the value of y first using Pythagoras here. So it will be y squared is equals to r squared minus x squared. Then the value of r is what? It's 4 squared minus 3 squared. That is the value of y squared. Then y squared is equals to 16 minus 9. This is 16, isn't it? Minus 9. 16 minus 9 is equals to what? Hello?
7.
7.
Yes.
Okay. Then the value of y is what? You square both sides. You square both sides. Square both sides. Then the value of y will be equal to what? The value of y is equals to square root of 7. That is the value of y. So we got the value of y.
So this
Wait, don't you say plus or minus 7?
Oh, very nice. Plus or minus 7. Ntabi saying you wanted to say something.
the screen is jammed. I can't see anything.
Okay. Okay. Let's go back here. What is wrong here? Anything now? Okay. Let's try again. Sharing the screen. Anything now?
I only see black.
Loading, nothing.
Mm-hmm.
Is it loading?
No.
And the problem that you can still hear me and then now you can't see, so that's magic. Oh. Anything?
No.
And Tabising,
Okay.
can you exit the meeting and come back again? Let's see whether the problem will be fixed.
No. It's back.
It's back now.
Yeah.
Okay, thank you. Thank you. Let's try to proceed. Tendo. Yes, it will be plus or minus the square root of 7,
Mm-hmm.
but the final answer will be y is equals to square root of 7 and y is positive. That's why I just wrote y is equals to square root of 7, positive 1 instead of writing plus or minus.
Okay. I thought that we were gonna go y equals to plus or minus 7 and then go, but y is a positive 7. I
Yes,
thought we were gonna do that.
yeah, that's correct. It's nice that you know all the steps, like the detailing step.
Okay.
Yeah, it's nice. It's nice. Yes, that's the way that it should be done. But if you don't do it in that way, it's not a problem, because what we are requiring here, it's y is positive square root of 7. Then we can now determine the value of tan what? Of tan x. We can now determine the value of tan x, which is what? Tan x is equals to what?
Is it 49?
49. Where is 49 coming from now?
Oh, wait, sorry.
Opposite of adjacent.
Yes, opposite of adjacent, which is y over x. Yes, opposite of adjacent, and type is saying. Then what is the value of y?
Square root of 7.
7.
Square root of 7 over what?
3.
3. Thank you. So your most important part was using Pythagoras to find the value of y. Using Pythagoras, then finding the value of y, a mark, and then your final answer. There is our 3 marks. Okay.
Mm-hmm.
Okay.
Thank you. Then if we are to go to 2.4, 2.4, it's the same problem. The same problem, but in this problem, it's a different scenario. We are told that tan theta is equals to 6 over 8. Okay.
Yes. Also to calculate the y, because we got the square root of 7. Isn't there the easier way of just taking the 3 and we add it by 4, which also gives us 7? But then, like, how do you put it for the examiner?
Let me check. Is this tender?
Yes.
Hey, you love shortcuts.
But I saw it in the textbook.
Let me see. You are saying we could have said 3 plus 4 is equals to 7. Then where will you take the square root?
Thank you. Oh, okay, yeah, I see.
Because I think what you saw is this one. R squared is equals to x squared plus y squared. And then they write their pi. I think this is what you saw.
Let me recheck it.
Yeah. And if this is what you saw, I just used the same equation. It's just that I only made y sub the formula, because if we are to substitute here, the value of r is 4 squared. That is r. Then our x is 3 squared plus y squared. Then if we solve for y squared, then we need to take 3 that side. That's why it was 4 squared minus 3 squared.
Okay.
Are we still happy?
Yes.
Thank you. Thank you. Let's go to this 2.4. Did you confirm, Tendo?
Oh no, they actually didn't just add it.
Okay. What did
Yeah,
they?
they did go cos theta. They used 4/5, right? So then they did go equals to x over r. So then they did the whole Pythagoras, but then on the side they just put 4 plus 5.
Okay. Let's see. What did you have there? The trig ratio was what?
Sorry,
What is the trig ratio?
cos theta equals to 4/5.
Cos theta is equals to 4/5.
And then we have theta is an element of 0 degrees and 90.
Theta is it's from what? 0 degrees.
Yes, to 90 degrees.
Okay, 0 degrees to 90 degrees. Okay, so more of this. It's I think it's more or less the same thing as this.
Yeah.
Yeah, it's the same. So you're saying that they did the diagram, right?
Yeah, and then they did Pythagoras as well.
So they did r squared is equals to x squared plus y squared, right?
They said x squared plus y squared equals to r squared, but it's like the same thing.
Yes, it is the same thing. Then let's substitute the value of r. It's 5 squared plus not plus equals to what? What is the value of x?
4
4 squared plus y squared.
Yes.
Then take 4 that side. That is 25 minus 16.
Mm-hmm.
Then the square root of 25 minus 16, that is 9.
Yes.
Then you have y squared is equals to 9. Then you square both sides. Square root of y squared is equals to plus or minus the square root of 9. And
Yes.
therefore y is equals to 3.
Yes, that's what they did.
So it's more or less the same thing.
Yeah. They
Just
also said a quicker method to solve for y. They said y squared minus 9 equals to 0. And then they substituted from then on. And then because the thingy, they rooted 9, which gave them plus minus 3. So they how do they get the 9? Do they add 4 plus 5 first and then say y squared minus 9 equals 0?
I don't know about that one. The y squared is minus 9, adding the 2. I don't know. I don't know about that. But we'll have to test it. Can we test it on this one?
Okay.
Yes, come in.
Let's test it on this one. 6 plus 8. What are we looking for here? What do we have? So in this one, we had the value of x and the value of r. So the value of y squared, we are saying it is going to be what? 7, adding the 2. Y squared is equals to 7. That's what we are saying, and then we will add and subtract them. So here we are looking for r.
Mm-hmm.
Are we going to say r? It's 6 plus 8,
Yes.
which is what? 14.
Yeah.
14, then r is equals to plus or minus the square root of what? Of 14, but r is always positive, eh?
Mm-hmm.
Okay, that's what we got by just adding these two. Okay, let's see when we use Pythagoras whether it will bring back to this.
Okay.
Then we will agree with your method.
Okay.
And we are proving this is math, there's nothing wrong.
Yeah.
Proving. Tabiseng, are you still with us?
Yes, sir.
Okay. Let's see, using Pythagoras, we need to find the value of r here. So r squared is equals to x squared plus y squared. So our x squared is 8 squared plus 6 squared. That is Pythagoras doing the substitution.
Mm-hmm.
And yes.
So isn't the 8 supposed to be a negative because it's under the axis?
Okay. I do get what our friend is saying there. Our friend Ntabiseng is saying because a sign is negative and tan is positive, it only means that our y is negative and our x is what? Is negative, because this sign can only be negative in which quadrant? In third quadrant or fourth quadrant. You see, they're saying sine theta it's less than 0. Do you see that?
Okay. Yes, sir.
Yeah, so it means that our right angle triangle is in this quadrant, because this is where tan is negative and tan is what? Not tan. Tan is positive, because negative by negative is what? It's positive. This is where tan is what? Is positive here. It's positive here, and sign will be negative here, because all students take cos. Sign is negative, it is positive in second quadrant. But here they're saying sign is negative and tan is positive. Where? Here in third quadrant. Okay?
Mm-hmm.
Then this will be our angle theta. This is part of the marks. And then the value of x, yes, will be negative 6. No, not negative 6, negative 8, sorry. Negative 8. And then the value of y will be negative what? Negative 6. There we complete our right angle triangle. Then we are left with what? We are left with the value of r, which is what we are looking for. So Ntabiseng is saying, instead of us putting positive 8 and positive 6, let's put negative 8 squared plus negative 6 squared. Is it true, Ntabiseng?
Mm-hmm.
Is this what we are saying?
Yeah.
Yes. So this is what we're supposed to do. So let's see. Yes, the answer here will be positive. That's why we didn't bother to put the negatives there. But this is a very wise move, and this is what you must do when you do your substitution, because it will catch up with you here when you do your substitution. If you put positives here, you will get wrong. The answer will be wrong. So let's see. R squared is equals to what? This is 64.
100.
Plus 36.
Yes.
Your theorem is not working, 10.
I see.
The theorem is not working, so no. That's why I told that I don't know about that.
Well, maybe it only works with y because they said quicker method to solve for y. They didn't put r.
Which textbook is that?
Mind action series.
Mind Action Series, grade 10. Which one? New edition or old edition?
I think it's new edition.
Does it have a stamp? New edition.
Yes, it has a yellow new edition stamp.
Okay, let me go and collect it. I do have that one.
Okay.
Just a second. Just a second.
Okay. Hi. Mine on.
It's page what?
Page 81 for the y method one.
Page 81.
Yes. But then they also have a quicker method for x squared. But I think it's different.
Uh, you know, Basonia sometimes takes chances. I know this guy. I met him, the owner of this book. I know him. Yeah, he sometimes takes chances. This method it cannot be applicable for R, but we'll have to check for Y for Y and for X whether does it work. We will have to do other problems and see whether is it working.
Okay.
Yes.
But then if you were the examiner and I used this method for y, like would you mark me the same as if I used Pythagoras?
If this method it works and it's applicable, it will mean then there won't be necessarily marks for Pythagoras. Then the marks will be on the final answer.
Okay.
Yes, if this method does work always.
Okay.
Yeah, that's what I'm saying. At the moment, I'm not really sure. I need to check on this method. Okay.
Okay.
So on the value of R, it's not working. So we need to check whether does it apply with X and Y. We need to check that. But it is very much advisable that as we teach, we use a standard method.
Okay.
Which is what we are doing here. So the square root of R squared will be R, and the square root of 100 will be 10. Let's take note before someone says plus and minus many. Let's take note that the value of R is always positive.
Yeah.
Yeah.
It cannot be negative. If a trig ratio is negative, it only means that X is negative or R is negative. No, not R, sorry. Or Y is negative. Okay.
Okay.
If a trig ratio is negative, it only means that it's either X or Y is negative, not R. The hypotenuse cannot be negative. Is that okay?
Okay.
Thank you. Thank you. There is the value of R, it's 10, meaning the method here didn't work. So we'll verify again. So there we have the value of R. Then let's answer the question. The diagram will be needed. This diagram, it will be needed if we can do it properly. This diagram will be needed. It will be part of the 5 marks. It must be there. So first of all, before we do any calculations, we will need to have our diagram in place. Let's see you, and then you. You. Let's go. We'll have to get our diagram in place. There you are, and then there you are. Then the origin, we indicate the origin. Here is the origin. And then where is our arm? Our arm, it's in which quadrant? Tan is positive and sine is negative. Which quadrant is that? We need to identify the quadrant so that we can get all the marks. So where tan is positive, you see here, you don't see any negative. So it means this is positive. So tan is positive. At the same time, they're saying what? And sine theta, it's what? It's less than zero. Less than zero, meaning it's negative. So which quadrant is that? That is quadrant 3. So meaning your arm or your right angle triangle must be in quadrant what? In quadrant 3. Here. So when we get to quadrant 3, we need to take note of these values. This is the value of y. This is the value of x. And in quadrant 3, x is negative. The values of x are negative, and the values of y are negative in quadrant 3. So meaning here we are going to have this point, which is going to be like our point P or a point A, which is going to be what? -8 and -6. So where is -6? Where is -8? This is -8. This is going to be our -6. So this diagram will be very important. This is going to be -6. Then indicate this is x, this is y. Please indicate how the angle is measured. The angle is measured anti-clockwise. This is our your angle what? Your angle theta. This is the angle theta. Okay. Then you've done the diagram, and then the next thing you solve for r using Pythagoras. So we will be happy with this. Yes, we're going to give you 2 marks. 1 mark for substitution, 1 mark for the value of r. Please write the value of r here. R is equals to 10. Then you have the value of x. This is x. Then this is y, which is -6. Then the next thing, you go and do the substitution. Your correct substitution will be as follows. Determine the value of, therefore, you write cos theta minus 2 sine theta is equals to, what is cos theta? Cos theta is going to be what? What is cos theta? Cos theta is what?
Adjacent over hypotenuse.
Yes, what is the adjacent?
-8.
Scroll it down like this block of the phone thingy. It's covering the graph.
Over 10.
10, I can't hear you.
I was asking if we can move the white paper down because the phone thingy with the hang up and stuff, it's like covering most of the graph.
So are you saying we must move this paper?
Matendo, press the screen. Did you do that?
Okay, yeah, it's gone. Thank you.
Okay.
You're welcome.
Okay. Okay. Cos theta is what? It's -8 over what?
10.
Thank you. There is your substitution, and then -2. Then your sine theta is what?
Hypotenuse. Opposite over hypotenuse.
Thank you. What is the opposite?
-6.
-6 over
10.
10. Thank you. So you have done a correct substitution. Please, let's take note the negatives. The negatives are very important. Then I will encourage you. They said without the use of a calculator, but to avoid losing marks unnecessary, I will encourage you to at this moment take your calculator, press open bracket negative the way it is, press on your calculator open bracket negative 8 over 10 close bracket negative 2 open bracket negative 6 over 10 close bracket, then you get a final to avoid making mistakes. That's why I'm encouraging that. Otherwise, what do I have here? I have negative 8 plus 12 over 10, which is equals to 4 over 10, which is equals to 2 over 5. You see? I don't really trust learners when it comes to this. You know, you guys will lose marks when you are done. So then that's why I say, no, instead of you losing the marks, just take your calculator and press this substitute the way it is. There we got the final answer. Let's see. We got 3 marks already, and then 2 marks for doing our. Did you get 3 marks? No, it's going to be like 1 mark here. 1, 2, 3, 4, 5.
It deserves like 8 marks. Yo.
Welcome to pure maths. But did we learn something here?
Yeah.
The most important
Yes.
thing in this question, the most important thing is to be able to see the value of y and the value of x when your trig ratio is in standard form. The second thing is to be able to connect to see whether the trig ratio is positive. You see these two, being able to connect in which quadrant are they. Okay.
Okay.
That is the most important thing, to be able to see which quadrant must I draw my right angle triangle. Then you can come to solving this problem. This problem, this is not a problem. The main issue is here. Okay. Thank you. There we go, 2.5, our last question. Trigonometry check, how many marks? 21 marks. So if you, yes, trigonometry, 21 marks. If you do your homework nicely, you might find yourself getting all these marks. And if you get 21 marks out of 50, that is 40%. And then if we go to number pattern, you check there, it's 14 marks. If you take all these marks, you are sorted. You're already at 30 something, 35 marks already. So let's look at our last question. Then we will have to check which question is that? The angle of elevation and the angle of depression before we come to this one, because it's just a walkover. Let's see. Without using a calculator, determine the value of x in the diagram. Can you do this one for me while I'm looking for that question? It's 2 marks. 2.5. Yes.
Can you please give me 2 minutes to get inside the house?
Okay, it's fine. 2.5 there for 2 marks. That is 2 minutes. 2.5. Yes, find the value of x. Let's see.
Sorry, the packer.
Oh, wait. Do it now.
Are you guys winning?
Wait, sir.
Thirty. Sir?
Yes.
Yeah, I'm lost. I don't know why, but I'm lost.
You guys. Oh. Okay, let's see on this problem. We are given an angle there, 30 degrees. We are given a side that is opposite to the what? To the hypotenuse. Then what are we looking for? We are looking for a side that is opposite. We're looking for a side that is opposite. So let's check again. What we have? Thank you. Stop shaking. So let's go again. We have an angle. Is what we have. The next thing that we have is the opposite of the hypotenuse. That is the opposite of the 90 degrees. That is the hypotenuse. We have the hypotenuse side. Yes, I have hypotenuse. I have the value of r. Okay. Then I have a side that is opposite to the given angle. So opposite to the given angle, I will call this one y. So r is equals to 1 to 50 kilometers. And then my opposite to y, it's what? It's x. This is what I'm looking for.
Okay.
So I'm looking for y. I have what? I have r and the angle. So which trig ratio am I defining here? Let's check again. I'm looking for opposite. I have the hypotenuse. I'm looking for opposite. Come again.
I think sin.
Yes. So this is sine 30 degrees is equals to what? What I am looking for, which is x opposite over the hypotenuse, which is 1 to 50 kilometers. Then you do what? You do cross multiplication, then x is equals to 1. That's why it's 2 marks. Okay.
Okay.
Okay, what is the value of x? In terms saying?
Sir?
Okay. What is the value of x?
um. Wait.
Let's go. 1, 2, 50 times sine what? 30 degrees. So 1, 2, 50 times what is sine 30 degrees? That is 1/2 special angle.
Mm-hmm.
Then this is 1, 250 divided by 2. 1 to 50 divided by 2, is it 6 something or what? 625. 625, Anne?
Yes.
625 kilometers. Anything?
Mm-mm.
Thank you. Are you happy with the problem? Did you see that it was easy?
Yeah, so you know what I did, Nick? After I multiplied the sin 30 with the 1250 there, then I got like I took this in the other side and like see then I got confused.
Okay, get your
But
maths together. Okay, so angle of elevation, that's what I want to talk about before I move to this topic. Let's check. Are you angle of elevation? Let's check angle of elevation. Angle of elevation. You are not here. Okay, you are not here. Okay, we don't have you here. Okay, it's fine. Let's go. On the angle of elevation, I don't have questions there, but it's not a big fish. Angle of elevation. Angle of elevation and depression. Angle of elevation and depression. Thank you. Let's see what do we have there. Angle of elevation and depression. First of all, the angle of elevation. When we talk about the angle of elevation, what are we talking about? Elevation. I hope all of us who can hear the word elevate or elevation, elevate in this statement to uplift. Okay.
yes.
So when we talk about angle of elevation, we are talking about the angle at which you look at an object that it's up there, that it's up there from where you are. So we are referring, if we have a building here, and then Tendo just went to Joburg for the first time, and then and here it's Tendo walking, passing these buildings. So I will put Tendo here. Here is Tendo. There is Tendo. Walking, Tendo. Tendo, it's looking at this building. Because you know, in Venda, there are no such buildings. So Tendo is looking at this building. Anne? So this is the angle at which Tendo is looking at this building or looking at the top of the building here. So the angle of elevation will be the angle at which Tendo is looking at this building from her eyes to the top of the building. So this angle, we'll call it the angle of elevation. Then if you look, are you with me?
Can you please repeat?
The angle at which you are looking at something that is up there, like Tendo here looking at the top of this building from where she is. So the angle at which she is looking at the top of this building, which is this point, it's called the angle of elevation. So this one will be your angle of elevation.
Okay.
Angle of elevation. Angle of elevation. And then Tendo is looking at who? At Ntabiseng, who is here at the top of the building.
Okay. Okay.
You see?
Mm-hmm.
Here is Ntabiseng. So Ntabiseng will be looking down at who? At Tendo. We call this one Peter. So Ntabiseng will be looking down. We'll call this one Peter. So this one is the angle of what? Angle of depression. So we are elevating, we are looking up. This one is the angle of depression. Angle of depression. Okay. So if you are with me, you will see that from where Ntabiseng is, we're going to take it as our normal or as our normal ground. So it will mean that from where Ntabiseng is and where Tendo is, the floors are parallel to each other. Can you see that? The floors are parallel to each other, meaning therefore the angle of elevation and the angle of depression. Okay, the angle of elevation looking at the same point or looking at a point, and the angle of a depression looking from the same point. Okay, the angle of elevation looking at the point and the angle of depression from the same point are equal. As you can see, they are alternate angles. Can you see that? Yes. So if you are with me, you will see that from this angle of depression, we can still create another a right angle. You see that? Then at this angle of depression, yes, look, an angle of depression at a point is the same as the angle of elevation at the same point. Okay, two
Oh, okay.
angles. You see, I'm looking at this angle, then this one is looking down at me. So we are looking at each other at the same angle. Therefore, our eyes will like catch up with each other because we are looking at each other at the same angle. Okay, so what do we use this scenario? We use this scenario to calculate the height of a building, because on normal circumstances we will have a building like this, and then we will be saying Tendo is looking at the top of the building. Tendo is looking at the top of the building. No. Tendo is looking at the top of a building. If you can just move it this way. Tendo is looking at the top of the building. Miss Peary, must be straight. There you are. Tendo is looking at the top of the building at an angle of
90.
no, it can't be 90 now. At an angle of 20 degrees. And then Tendo, it's 5 meters away from the building. There it's Tendo. Tendo, it's 5 meters away from the building. And it's 5 meters away from the building. Okay, there is your building. This is the building. This is the building. So Tendo, it's 5 meters away from the building, meaning from here to where Tendo is 5 meters. What would be the question? The question might be, what is the height of the building?
So do we use the same method as the previous question?
Yes, this is just an application of trigonometry in real life.
Okay.
So what is the height of the building? You'll go there. Okay, what do I have? I have adjacent to the angle. What am I looking for? I'm looking for opposite. I have what? Adjacent. I'm looking for opposite. I mentioned two words. I mentioned adjacent and opposite, meaning I'm talking about what? Tan. Tan.
Okay.
Tan 20 degrees is equals to what? The height of the building. Maybe there it's A, B, C. So the height of the building will be about AP, which is opposite over what? BC, which is tan 20 degrees is equals to AB over what? Over 5. Then you do your cross multiplication. AB is equals to 5 times what? Tan 20 degrees. So the answer you get here will be the height of the building. Then here is another question on this angle of elevation. And Tabiseng is climbing. Is climbing. What is it? The roof. You climb the roof. No English sometimes. Tabiseng is climbing the roof using a steps or a ladder of 5 meters. The ladder of what? Of 5 meters. This is 5 meters at an angle of 35 degrees. The ladder is leaning to the wall at an angle of 35 degrees. So this is 35 degrees. Then the question might be, what is the height of the wall, or how far away on the ground is the ladder or the step? You see what you have? You have the hypotenuse side. They might ask you for opposite or the adjacent.
Okay.
Yeah, it's just the application. So whenever you do the angle of elevation and depression, the only thing that must be in your mind is a right angle triangle. How you're going to construct it. Is that okay? Yeah. The only that must be in your mind is the right angle triangle. How you're going to construct it. Just listen to that English, the one that they'll be telling you what is happening. You see that they said the ladder is 5 meters. The ladder is right. Then oh, this is the ladder, so it will be leaning on the wall. So when it leans in the wall, what angle is created there? Okay. Yes. So it only means that this is all about angle of elevation and depression, unless you have patience.
So can you try,
Yes.
I
Yes.
can try the question on page 78, number 2, box 2.
Page 78. Page 78. They page 78 number what?
B2.
Oh, the size of the roof. So let's have this problem on here. It is a very nice problem. Very nice. If we can just move to the side. Let's have this structure into shape. We'll use you now. Let's go. Let me not wait for you. Let's go. To shape. Into shape. Thank you. Then let's go. Something like this. Thank you. Then this is what 7 meters. This is A. This is B. This is theta. Then this is your 90. They wrote here roof. And then it's E. Then B, F, E. Then here it's 30 degrees. And then here it's 10 meters. Then it's point C. Okay. So number 2 there, they're saying calculate the size of theta, the length of elevation. Calculate the size of theta, the angle of elevation. The angle of what? Of elevation. We are elevating. Of elevation of the top of the roof A from the ceiling BCD. So your ceiling is BCD. There is your ceiling. So you wanna find the top of the roof. So before we can calculate the angle of elevation here, we will need the length of BC.
Okay.
Because we need this angle. So we need at least one side. We need at least AC or BC. Okay. And then we can see here from the diagram that FE is 10 meters. And then from what we can see here, we can see that here it's the 90 degrees. Also here it's 90 degrees. And then we have this angle, which is 80 degrees.
Yes.
Okay.
Mm-hmm.
So from this length FE, if this is a rectangle, it will mean that BD is also 10.
Mm-hmm.
We need to read the number P. But they're saying that an architectural design of the front of a house is given below. The length of the house is to be 10 meters and exterior stairway leading to the roof is to 4 and angle of the ground level. The standard part of the roof must be 7 meters in length. Calculate the height of the vertical wall DE. So we've calculated the height of the vertical wall EE. Okay, if we get DE, we will be able to get what? FD. But getting FD, will it help us to get BD? It might help. It might help us also. At the same time, we can tell that BD is equals to FE.
Mm-hmm.
True or false? Okay, let's go. BD is equals to what? FE, but we need to prove it that one first. How do we prove it? We are going to get the length of DE first, which is what they required there. So I'm looking for DE, which is opposite to 30 degrees, and then I have an adjacent side, which is 10 meters, adjacent to 30 degrees. So I'm looking for opposite, I have adjacent. That would say this is tan 30 is equals to what? DE, opposite, over what? Adjacent, which is 10. Then I cross multiply, DE is equals to 10 times tan 30. 10 times tan 30 degrees. So tan 30 degrees is equals to what? That is 1 over square root of 3. 1 over square root of 3. So DE will be what? 10 over square root of 3. You can confirm with us the 1 over square root of 3, that is tan 30, special angle, 1 over square root of 3, that is tan 30, and then 10 times tan 30, that is going to be 10 over square root of 3 or 10 root 3 over 3. So that is the length of DE. So the length of DE, we got you. So having the length of DE, we can tell that the length of DE is the length of what? Of DF.
Mm-hmm.
Or of BF. The length
Yeah.
of DE is the length of BF because it's the opposite side of a rectangle.
Yeah.
Mm-hmm.
Okay. Then
So,
yes.
so is it eligible to write the reasons?
Yes, you must write the reasons. But the problem is that are we told this is a rectangle?
Mm-hmm.
Is there anything that we think is a rectangle? There's nothing like that. There's nothing like that. But we
Okay.
can assume from the diagram that this is a rectangle. But then we got the length of what of this DE. Having the length of DE, and then if we assume this is a what? This is a rectangle. We can agree that BD is equals to 10 also.
Okay.
Then if BD is equals to 10, the next thing that we need to prove is that BC is equals to CD. Okay. How do we prove that BC is equals to CD? We look at this triangle and this triangle. Are these two triangles congruent to each other? Yes or no? The answer might be yes. How are we going to say they are congruent? Let's look. BA is equals to 80. Reason given. Okay.
Yeah.
BA is equals to 80. Reason it's given.
Yes.
Okay. This was your number one. Then your number two. Well, what are we going to do? We're going to say, okay, FE is equals to BD. Then this is what opposite side of a rectangle or a parallelogram. Opposite side of a rectangle. Side of a rectangle. Okay.
Okay.
And then so F is equals to BD, opposite side of a rectangle. This is number two. Then having that, the next thing we write in triangular what? A, B, C, and triangular what? A, C, D. No, not ACD. ADC, ADC, sorry. ADC. If we can say this is our C1, this one is our C2, then we will say, therefore, in these two triangles, we have AB. AB equals to what? AD. Yes, AD is equals to AB. Reason, it's indicated, it's given. You're going to say given. The next thing, we're going to say AC is equals to what? AC. Can you see that?
Mm-hmm.
AC is equals to AC. Reason, common. Angle C1. Angle C1 is equals to angle C2, which is equals to 90 degrees. Reason, this is given. It's indicated in the diagram. Then what do we say? Therefore, triangular ABC is congruent to triangular what? ADC. Our reason would be right angle,
Hypotenuse.
hypotenuse side, and a side. So your hypotenuse side is which one? It's AD. And your side, it's what? It's AC, the common side. And then your side, your hypotenuse, your what? Your right angle, it's what? Is that 90 degrees? So if these two triangles are congruent, what do we say? Then BC, is it BC? BC is equals to CT. Then BC is equals to CT. If BC is equals to CT, that will mean they're equal to what? 5 meters. Means F is equals to what? 10 meters, and F is equals to what? ET. So we have proven that here it's 5. If here it's 5, then it means what we have? We have the adjacent to theta and the hypotenuse. We have the adjacent and the hypotenuse. We have the adjacent and the hypotenuse. Which trig ratio is that?
Uh,
I have the adjacent and the hypotenuse. I have the adjacent.
cos.
Thank you. That's how you see which trig ratio you must use. What do you have? What are you looking for?
Okay.
So I have the adjacent and the hypotenuse. So that is going to be cos theta is equals to adjacent is what? It's 5 over the hypotenuse, which is 7. Therefore, theta is equals to cos inverse of 5 over 7. And what is your final answer?
Okay.
What is your final answer?
44,41.
44,41.
Yeah.
Is it 44,41?
Or 44 or 42.
44,41 or 44,42?
42.
Thank you. There we got the angle. Then look at the next question. What are they saying there? The length of the beam AC. It's now obvious. Now you're going to use what Pythagoras theorem, right?
Yeah.
And then this is why. So let's test Tendo's theorem. This is why. So are we going to say Tendo's theorem? What is it? 5 plus 7.
No, it's not a fraction.
It's a fraction. There it is. It's a fraction. There, yeah. Yeah.
Let's try it then.
It's a fraction, 5 over 7. So let's try. Tendo's theorem says AC squared is going to be 5 plus 7. That is 12.
Yeah.
Then AC is equals to square root of 12. This is Tendo's theorem. True or false?
Plus or minus the square root of 12.
Plus or minus square root of 12. Therefore, AC is equals to square root of 12 because we are referring to a length here. A length cannot be negative. So let's prove this using Pythagoras. Whether it's correct. Let's see. This is R. So AC is equals to, or AC squared is equals to what? 7 squared minus 5 squared. So this is 49. This is 49 minus 25. These are according to Pythagoras, not Tendo's theorem. So let's go. AC, what do you get? Yes, AC squared is equals to what? 49 minus 25?
24.
24.
Yeah.
So again, Tendo's theorem is failing.
I blame the textbook.
I told you.
So he's lying.
No, not lying is lying. Maybe we might have misunderstood the contents there. No, that is lying.
Okay.
Yes. Might have misunderstood the context. Okay.
Mm-hmm.
I think we are done. We should go to these questions now. The similarity.
Oh.
The congruence
Proving.
3.1. Can we?
Yes.
Prove.
It's very straightforward, guys. Very, very straightforward.
I know
Is
the
it hard?
answer.
It's very straightforward. Let's go on this one. It's very straightforward. Use the diagram below to prove that the opposite side of a parallelogram are equal.
AB is equal.
Yes, prove that AP is equal to what? CD. How do you prove that? But hint, prove that triangular ABD is congruent to triangular what? CDE. It's very easy.
AB
I'm going to
is parallel to CD, and then the angle D, the whole thing, angle B to the quad is equal to C D, something at C D.
okay. In 3.1, so we'll write there in triangular what? A, B, D, and triangular CDB. What we have? We have angle what? A1, where, oh, not angle A1, angle A, this angle, look, angle A and angle C are equal. That's how we see it without even looking at that diagram. Then we move to angle B. Angle B, or we take AB, or let's go angle B. Angle B, B what in this triangle? Which triangle are we looking at? We're looking at ABD. ABD. So that would be B2.
Yeah.
This angle B2 is equals to what? Angle D what? We're looking in this other triangle, which is this one. Angle what? D2.
D1.
D1. So
Yeah.
D1. Then the next thing, because you are proving congruency, are you with me?
Yes.
Because we are proving congruency, we must have at least one side in our proof. So our side we're going to use BT. Look at BT. BT, it's here. It's also here. So we have done angle B and angle D. You see? Exactly. The next thing that we could have done was going to be what? Angle D is equal to angle B, which is going to be what? Angle B2 is equal to angle B1. That was going to be. But because we are doing congruency, we must have at least one side proving that. So the side that we are looking at, look, we have BT here. We also have BT here, though it's DP. So we'll write there BT, and look at BT. BT is equals to DP. This BT is here. It's also here. It means this is common because it's in both triangles. Common. Yeah, this one is BT, also this one is BT, so it's common. Then the next thing, you look for this angle. B2 is equals to D1. Let's check that it's a Z. That's a Z.
Alternate.
Yes, alternate angles. That's a Z. We'll write the alt angles equal, comma, AB is parallel to what? To DC. You must have that. Parallel to DC. Then you close. Then on this one, what I'm going to say, third angle of a triangle, third angle of a triangle, or opposite angles of a parallelogram. Or you just say third angle of a triangle. This reason, it's going to help you a lot. This third angle of a triangle, you need to remember it always. You find two angles, then on the last one, you say, This is that angle of a triangle. Then it's done. You only need to look for 2. Then the next thing, you write there the conclusion. Therefore, triangular AED is congruent to triangular CDB. If they are congruent, why are you saying they are congruent? That is angle, side, angle. Angle or angle, angle, side, or angle, side, angle. Okay, there is our reason why they are congruent. So if they are congruent, it means that they are exactly the same. Not even identical twins can match with this one. These ones, they're exactly the same. Meaning that this side is equal to that one. This side is equal to that one. So then we'll write then A B is equals to what? CT, exactly what they're asking there. And AD is equals to BC. Okay. That's exactly what they're asking there. Then we come to this one, the easiest again. Let's read what they're saying. In the diagram below, KLMN is a parallelogram. Usually this is a present statement. If you say something is a parallelogram, that's a big claim. You know what you are saying by that statement? You are saying this angle is equal to this angle. This angle is equal to this angle. By just saying it's a parallelogram. Okay, look at the first question. The value of x. He told us it's a parallelogram. What are we going to do? We're going to write there. Angle N is equals to angle what? L. Reason, opposite angles of a parallelogram or a palm. Abbreviation for a parallelogram is a palm. Angle N is equals to angle what? L. Then we get 1 mark. Then the next thing, what we do the substitution. Angle N is what? It's 7x minus 30 degrees, which is equals to, that is angle N. Angle L is equals to what? 5x plus 18 degrees. Then what we do? Let's transpose. Collect like terms. Yes. 7x minus 5x is equals to 18 degrees plus 30 degrees. This is 2x is equals to 48 degrees. X is equals to 24 degrees. 4 marks. Substitution, simplifying, final answer. 3 marks, Anne. Let's go. If it is further given that LK, let's go. What are they saying? If they write something like this, what do we do? They said LK. Where is LK? There is LK. Do you see? LK, and then they say KN. Oh, this one. So which angle are we talking about? We are referring to you. We are referring to this angle. Is equals to 4y. Determine the value of y. If LKN is equals to 4y, also LMN is equals to 4y. Because it's a what? It's a parallelogram. Because it's a parallelogram. If this one is 4y, also that one is 4y because it's a parallelogram. Right, so if you say something's a parallelogram, it's a very big statement. You can't claim that unless you afford it. So let's see. 3.22. what I'm going to say, LKN is equals to LMN. Then we write our reason, opposite angles of a parallelogram. Opposite angles of a parallelogram or opposite angles of a palm. Then we get 1 mark for that, or they don't even give us, it's fine. Then what do we need here? We need the value of y. 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 Oh. Hey, there is something, it's like we've done a mistake here. Are they supplementary or? Oh, yeah. This one won't help us. Sorry. This one won't help us. It won't help us because it won't give us a solution. But if we use co-interior, this angle and this angle are supplementary. Co-interior. Okay.
Okay.
Yeah, sorry. So I'm going to write the angle what? Angle L plus angle what? K or LKN is equals to 180 degrees. Sorry. Then we write the co-interior angles are supplementary, comma, LM is parallel to what? To LN. Then what is angle L? Angle L is 5 x plus 18 degrees, not 180, plus 18 degrees. Then what is angle K? That is 4y is equals to 180 degrees. Then 5, the value of x is what? Is 24 degrees plus 18 degrees plus 4y is equals to 180 degrees. Then 5 times, let's add 5 times 24 plus 18, 4y is equals to what? 180 degrees minus 5 times 24 plus 18.
138.
138.
Yes.
Okay. 138. So that is minus 138. Minus 138 degrees. Therefore, 4y is equals to what? 4y is equals to what?
42.
42 degrees. Therefore, y is equals to what?
21. Do I put it in decimal form?
Decimal.
10.5.
10.5 degrees. Okay, we are moving, making progress. There is the value of y, we got the value of y. Let's take note, just to make sure that our statement is correct, the value of x, it is equals to 24. The reason why we're saying that is because a rectangle, it's a parallelogram. Do we know that?
Mm-hmm.
A rectangle, it's a parallelogram. So we want to confirm our claim that opposite angles are equal. So let's see, in a rectangle, just roughly so, in a
Two opposite sides.
two opposite angles, it's 90 here, it's also 90 here, it's also 19 here, it's also 90. Do you see that opposite angles are equal?
Mm-hmm.
Yes, that's why we're saying this angle and this angle are equal. At the same time, one can say opposite angles of a parallelogram are supplementary. Is that true? No, it cannot be true. Why we are saying opposite angles of a parallelogram cannot be equal to 1 180 opposite angles. Let's look at this scenario. There you are. Sorry. Let's look at this scenario. Thank you. If we can have this angle maybe being equals to what, 60 degrees. Remember, this is parallel, meaning this is co-interior. Then if this one is 60 degrees, it will mean this one is what? It's 120. So if we check here, this is 120. This is 60 degrees. 60 plus 120, that is 180. That is co-interior property being proven. And this is a parallelogram. So opposite side of parallelogram are what? Are equal and parallel. Opposite side of a parallelogram are equal and parallel. So if this one is 60, this one is 120. So check. Here we are going also to have 120. 120. This is going to be 120. Then this one will be what? 60 degrees. Then if you look at opposite angles, the opposite angles, look, opposite 60 plus 60, they are not equal to 180. So it means therefore angle L and angle N are not equal to 180, but they are equal. That's what we know of. Is that okay?
Mm-hmm.
Yes. So I just wanted to make sure that our answer is correct in what? In 3.2.1, that yes, opposite angles of a parallelogram are equal. They are not supplementary. As you can see, 60 plus 60, it's 120. Okay.
Mm-hmm.
Yes. So that is 3.22. Then the last question, taking you back to grade 9. Back to grade 9, similarity. We are almost done, guys. Back to similarity. Let's see, what are they saying here? FT is equals to, where is FT? FT is 5 centimeter. ET. They've given you length, EF, CT. Okay, what are they saying here? They're saying prove that a triangular EFT is similar to triangular DCT. So when they give you something like this, you need to check on the diagram. What did they give you angles or side? They gave you side. Then if they gave you side, it will mean therefore. Are you with me?
Yes. Mm-hmm.
Okay, I'm going to just show you. Since they gave you side, it means you're going to prove it by proportionality. If they gave you angles, you're going to prove it by angles. Okay, so 3.1, 3.3.1, very straightforward. 3.3.1. We have in triangular EFEFT and triangular DCT. Okay, what do we have there? What do we have? We have EF. I want to show you just from what you see there in 3. What exactly what they've given you in your question. So I want to show you a solution from your question. We're doing this. They're giving you side, so you're going to use side. So you will say, okay, in triangular EFT, what do we have? We have EF. Look at EF. It's here. Over DC. Look at DC. The first two alphabet, is equals to ET or FT. Look, ET, I jumped F. Then I will say this is over what? DT. Very straightforward. Your solution is there. This is 4 marks for free. Okay, ET over what? DT. And then the next thing you took ET on the numerator. So this one will be on your numerator, this one will be on your denominator. So you said EF, the first two, EF over what DC. That's what you did. You took the first two, divided by each other. Then you took the first alphabet and alphabet, ET over DT. And then this is equals to what? Let's see. FT. We're left with FT, the last two. FT over what? Over CT. Okay. This is what we've just written. Or you could have like put them separately, like this. Put them separately. EF over DC is equals to what? And then ET over DT is equals to what? And then FT, not DT, DT. Then FT, the last two, over CT is equals to what? So let's see EF. Come back to the diagram. EF is what? It's 9. You see that? EF is 9 over DC. What is DC? DC is 18. Can you see that?
Mm-hmm.
And then let's go EF. Did I do EF 2 times?
Yes.
That was supposed to be ET. ET, not EF. ET. ET. Let's see ET. ET is 7. Can you see that? ET is 7? 7 over, and then let's get DT. DT, it's 14. Are you with me? On the diagram itself, the diagram itself is giving you the solution. Then FT, where is FT? FT, it's 5. Over CT, CT is 10.
10.
Then let's get the solution. This is 1 over 2. This is 1 over 2. This is 1 over 2. Yes or no?
Oh, yes.
So your solution is here. The only thing that you need to check, are you with me? On the diagram, they give us angles or sides. If they give you sides, you do this. Then you conclude, therefore, EF over DC is equals to ET over DT, which is equals to FT over CT, which is equals to 1 over 2. Then triangular EFT is similar to triangular what? DCT. And then what would be your reason? Corresponding sides. Corresponding sides are in equal proportion. Okay. Grade 9, honey?
Yeah.
Okay, guys, I don't want you to stress. My point is that on this question, when they ask you this question, check. This is similar. Check what is that they give you. And do exactly. If they give you the sides, do exactly what I've just showed you. But if they've given you angles, this is what they're going to do. You will write that, okay, if they've given you angles, if you can do it here. I want you to focus here on this one. If given angles, if they've given you angles, if they've given you angles, what are you going to say? You're going to say angle E is equals to what? Angle what? D. They've given you angles now. Look, this one is equal to that one. Angle E is equals to angle D. Are you with me? And then you write angle F is equals to angle what? C. Then write angle T, maybe it will be T1, that's what they wrote double T's. T1 is equal to T2. Angle T is equal to angle T. Look. So, you see? You draw like that smiling face. If you can just have this thing here. That's a little triangle E F T similar to triangle DCT. This T, man, not O. DCT. DCT. So what you're going to do, you're going to say, okay, angle E is equals to angle. Look at the shape that I'm drawing here. I'm drawing you can even put a face here and do a smiling face here. These are the eyes. And then look. You see? This angle is called that angle. This angle is called that angle. This one is called to that angle. Then what you're going to put reasons here. Obviously, like angle T, it's just angle T, that will be like vertical opposite angles. Then there will be like reasons, like the alternate angles on the other diagram, if you remember. Then you write your conclusion. That one is done. Therefore, triangular what? E F T is similar to triangular DCT. It's D, it's D. It's D. Why do you keep pointing us? DCT. Okay, let's switch off this thing. DCT is similar to triangular. Okay, it's similar. EFT is similar to triangular DCT. Reason, angle, angle, angle. Okay, if they've given you angle, that's what you do. So in this question, guys, it's if you check here, I have dealt with similarity. On the other one, I dealt with congruency in a very nicer way and able to show you that the solution is exactly on the question itself. Here, angle A is equal to angle C. Let's see. Angle A is equal to angle C. What is the reason? Opposite angles of a parallelogram. BD is equal to DB. Common. Can you see that?
Yes.
Okay.
Mm.
Are you happy?
Yes, sir.
Guys, I wish you all the best on your test that you're going to write. I'm wishing you all the best. I just hope that all of you are able to capture the maximum marks. I believe that if I can send you, maybe, should I send you this paper?
Yes, please.
Okay, I will send this paper to you guys and then you work on it. Use it to practice. It can help. Don't forget the number patterns, Anne.
Okay.
Yes. Thank you, thank you, thank you. We had a very long lesson, but I hope it was profitable. And